let's receive with the applause Dan. Dan, it's all yours.
Hello, hello. What a day, huh? We had so many amazing talks. We talked about architecture, DDD, even system design, and now the last talk of the day feels more like this. Like, we're going to talk about front-end. Any front-end developers in the house? Okay, a couple. I was scared. When I checked the lineup, I was like, okay, it's going to be just like one or two front-end developers, but I'm glad you came. So to start, 3 years ago, I had a really big decision on my plate. I was trying to change my job, and I was thinking about either still being a software engineer in a very big company with over 1,000 engineers, or I can choose to be like a technical co-founder with equity in the company to build software from scratch. And I realized that I really love to build things, and all my life I was building a lot of stuff as a side hustle, but I never finished them. I always leave them with the doors that are missing, the windows and the doors, if you know the meme. So I decided, okay, this was the perfect opportunity to experience building something from 0 to 1. And of course, I tried this before. Like, I tried it as a side gig to build a startup. It never worked. And because I was following this pattern, I had an app idea, and then secretly I would build an MVP. It would take me 3 months, 6 months on my own, coding on it, full stop. And then I would be ashamed when I finished the MVP to show it to people. I wouldn't show it to friends. I wouldn't show it to family. And maybe I will try to probably get some funding. I would reach out to Y Combinator or Tiny Seed or something to make my dream come true. And it never worked. And when they say that 99% of startups fail, it's the startups that follow this formula that actually fail. Now I started my own company, and I realized that these pillars have to go hand in hand. So we did with the current company called CareerOS, we validated the idea without any money spent. And then when we got responses, we sent emails to investors, which usually invest in higher education because our product was a higher education product. And we didn't try to get money. We just gauged their interest. We just asked them for feedback, and investors really, really love to give feedback. And we did all these 4 pillars at the same time for a couple of months before we even tried to raise money. And it was a success. So how did we do this? We collected the emails of around 30 decision makers from schools with buying power, and then we sent them emails like this, cold emails, with just the idea. We didn't have a product at this point. We didn't have nothing. We didn't have a team. It was just me and my 2 co-founders. And even though it was Christmas holidays, when we sent this, we got around 20 or 30 responses back. And 3 of them became actual clients in the first month of our product. And then, only then, we decided to start building the product. And we started this newsletter where we invited investors, where we invited other potential clients, and we sent them our progress every month of what is happening. Now, in the email, we were mentioning that we send this to all sorts of people, like friends, family, mentors, but we were actually just sending them to clients. It was our way to gauge FOMO and interest. And when I decided to build a product, I chose a very simple tech stack, React at the front end, which was surprising because previously I only worked with Angular and Vue. But because I had the experience with Angular and Vue, I decided to choose React. We chose Go for the backend because it integrated really nice with Google Cloud, and it gave us the speed to market that we really, really needed. And then we created a couple of micro frontends in Node and Python. Now, in choosing the tech stack, my biggest fear, of course, was being left behind. So I made some rules to make sure we can always upgrade our stack or change it completely if needed be. Which was, I'm not going to use any framework-specific UI libraries I'm not going to use framework-specific third-party libraries, and I'm not going to use any no-code tools inside of the project. And I was also deeply impressed with how NASA and the world have managed to build the International Space Station. Now, if you don't know, the ISS was built in 1998 and continued over 30 assembly missions. And each mission, they send one of these modules in space, and they assemble it in space. And the way that this was managed to be done is each module has the same ports and adapters as every other module, and it can be taken out and moved and taken out and moved in different parts of the station. And when I designed my app, I wanted it to work the same way. Using terms from domain-driven design, I wanted to create multiple modules, and each module can be connected with other parts of the app through ports and adapters. So in front end, we had like components, hooks, types, and reducers that we wanted to use inside of our project. And here is an example of the folder structure that I had in mind. So the modules themselves each were broken by entities. We have like an account, analytics, cart, catalog, category. And inside of each module, we had the same structure. We have components, we have our data layer, we have our integrations, libraries, our pages, our router, and our index file that exported everything. The main idea behind it is at any given moment, if we want to move to micro frontends, we can easily just take out this module and move it somewhere else. And because of this, we had some rules, like we can't have interdependencies between modules. We need each module to be very, very independent. And each module had to have very, very strict guidelines for this to work. So we wanted to have like a style guide. We needed to build a component library. And we needed all modules, like I said before, to be encapsulated. And even more, you can see like the folder structure is very similar to a very familiar one, which is building by features. So you break down your app into features, and then you do the same. I call them modules, but you can easily do this with features. And the main rule is to never import components directly from that module. You don't go /features, profile, components, user profile. You just import directly from features profile, which is the main index. And you can actually restrict this with ESLint to make sure nothing like this happens. You can create your custom rule to make sure everything is perfect. And of course, these are all rules, and we love rules, but everyone has a plan until they actually get punched in the mouth. Mike Tyson said this, and the first problem we had was actually, I didn't want to have third-party libraries inside of my app. But, you know, stuff happens, and I had to add drag and drop. First, I tried to build it myself. It took so many times. It didn't work very well. And obviously, other platforms had really good drag and drop. So, OK, let's add React Beautiful DND. Then we had to use Firebase. We had to add Firebase. Then we needed some charts. So we had to add chart.js, React chart. Then we needed some analytics, Sentry, Mixpanel, and it got way out of hand. At this point, we have like 70, 80 third-party libraries currently in the app, which is something I really, really dreaded, because previously, I knew how hard to migrate from one version of your framework to another gets blocked by these. Like they don't allow you to go, you have to upgrade them. Some are legacy, some are deprecated, and you don't want that to happen. So what did we do? For each third-party tool we added, we actually created a wrapper component that exposed an interface that we use in different parts of the app. That way, if we ever needed to replace Mixpanel with something else, we do it inside of the wrapper and not directly in the party. And of course, for this to work, you don't import directly from inside of your component from React Beautiful DND. This is a rule that we don't use. Inside of components, we just import from the wrapper itself. We don't import from packages directly. So when this happens, when React DND, beautiful DND, gets archived and it's deprecated by Atlassian, then you can very easily go inside of your wrapper component, it was how it was built. So we were importing the React Beautiful DND at the top, and we replace it with, at the bottom picture you can see we're now using Draggable from Pragmatic Drag and Drop, which is the new library for drag and drop. And then we just replace it and make sure it exports the same interface as React Beautiful DND. Because our app was very drag and drop heavy, we were using drag and drop in around 100 or 200 files. So having to replace drag and drop in 200 files, even if you go meticulously one by one, it's going to take so much time and it's very prone to mistakes. And doing it in just one wrapper component is so much easier. It's very, very easy to do. And this was not everything we did. For example, the port and adapters that I like when you have multiple components of the same type. Like we have analytics modules, right? We send to Mixpanel, we send to June, we send to Google Analytics, Customer I/O, whatever. We're sending events from our platform everywhere. We don't want to have inside of our components track Mixpanel, track Google Analytics, track. So we create a wrapper component and adapter that you can plug and play as many adapters as you want. So another example is with authentication. If you're going to have like Google Auth or Facebook or GitHub, you can just want to plug and play them inside of a adapter manager, and then it works seamlessly across of your company. And this is how we did it with our track event. We created one track event function, and inside of it, we just add all the track events that we have. So we have track with React, Google Analytics, with AppQueue, CO, Hotjar, whatever. And inside of our component, we just call track event, and we don't care where this track event is going. So if we have to remove Mixpanel, we can remove it from just one file. If we have to add something else, we can just add it here, and all the events are going to be sent to it automatically. Now, I don't know who's built like with React, if you want to make requests to your backend service. You know, like this is a common like bad practice of doing requests to your backend. So you have a use effect, you have to track if it's canceled, loading states, errors, then you make the request, you set the data, you catch the error, you set it, and then you finally set if it's loading is false. It's a lot of boilerplate. You have to do it in every part of your app, and it gets really, really messy. And that's why I really, really love TanStack Query. Has anyone used TanStack Query here? React Query? It's really, really good, and it takes this boilerplate into just this. So you have your use order that uses your TanStack Query function, and it gives you, by default, it gives you the data, there is loading, there's error, the error, if it's refetching, and all sorts of state. It's a very, very good, I would call it a state management system for your data. But it also has a lot of things that it does for you behind the scenes. For example, if you're importing use order into two different components, it can actually share the same data. It won't refetch, it won't make an extra GET request for use order ID. And you can set a cache level and TanStack Query level to say, okay, only refetch every 8 hours. Or you can refetch it every time you visit the page. But it has this caching mechanism and reusability around components that if you wanted to build it yourself, you had to create a context, have a React hook inside of the context, get the data there, and share it across components. And this comes out of the box, which I think is really, really powerful. And of course, it also has some defaults, like it can retry. If your network request fails, it can retry to make sure it works again. For example, if you have race conditions, you wanted to retry to see if the data is there. So like I said, it has some parameters. You give it the query key, which is very important. This is how it stores the cache of the function. Then the function itself, which is basically your method to get the data. And you can specify stale time, how long this data is fresh or cached is what you can control. And then we have the revalidate function, which if you want to make the request again, you just call this query client invalidate query, you give it the query key, and it makes the request again. Now, it also has an option to optimistically update the cache. So for example, if you're making a post request, you successfully saved or you made an order, inside of your orders list, you don't have to refetch the list 100%. You can actually just refetch it. You made the post request, you get the resource back, and you can optimistically update the cache with the new result inside of the query. Which was something we were actually not doing in my company. So we had this dashboard where we were doing a lot of requests because we had like gamification, so you could like save companies, save contacts, whatever you were doing, and you got like badges and challenges, and at the top you can see we have some XP, you have levels, and because we have all these sort of things happening at the same time, so we're making a lot of requests. And the type of requests we were making were very, very short, but when you had hundreds and hundreds of people making the same request at the same time, our CPU was reaching, our DB CPU was reaching 98%, 99% of its capacity almost every day. And the reason for that was because we were revalidating everything, and we were using the backend as basically a state management system, which was not ideal. Obviously, it worked when we had 100, 1,000, 10,000 users, but when we reach 100,000, this became a serious problem, and we had so many downtimes because of it. Then we switched from revalidation to using Zustand, a very, very small third-party library, which we use to keep in our store the XP, the levels, the challenges, the badges, and we were never making multiple GET requests to the same endpoint. We were always optimistically updating the state that we had locally inside of our app. And of course, we also had a couple of chat WebSockets inside of our app. And here again, we had a really big problem because people were opening the chats they were having in multiple tabs. So they were keeping like 5 or 6 tabs with the same contact and having multiple discussions. And this what was doing, because we were using create WebSocket inside of the app, it was creating multiple WebSocket connections to our backend. And it was really, really increasing our request count. And we had our Cloud Run was consuming a lot of memory. So what we did? We decided, instead of having just one WebSocket client inside of our React app, we moved the WebSocket client. This is a normal WebSocket client that you usually build inside of your application. And then we decided to move that in a shared web worker. So we thought about multiple options to solve this issue. The first one was using the broadcaster API that the browsers give you, and just have a singleton WebSocket and use the broadcasting API to share data between tabs. But it was not working 100% of the time, and it was creating a lot of problems. So then we created our shared web worker client, and inside of it, we were using the WebSocket connection. So the web worker was creating the WebSocket connection, and inside of our application, we were only checking if the shared worker exists, and if it does, we just connect to it, and we send the messages and get messages, and if it's not, we just created it then, and we set it inside of the shared web worker, which I think worked really well. Right now, every time we connect to our application, we only have one WebSocket connection, and it reduced the number of minutes our connections were being saved at the same time. Now, all of these building blocks that you saw in my application before, if I show you again, a little bit back, all of our interface is composed of different elements, different components. It's actually pretty big. So when we started, we decided we need a design system. So our main part of the app, we have a core UI where we keep our tokens, our helpers, our styles, our components, and we started this from scratch. We never built something in React without being a component in Figma. And this helped us be very, very fast. Our PMs can drag and drop in Figma a new design, and because we have everything in a design system, it's very easy to build going forward. And if you don't know what a design system is, standards, documentation, and reusable components that guide the development of digital progress. It's a single source of truth for designers and developers, and we have like style guides, fonts, spacing, typography, everything is in one place. And Figma directs the designers are the source of truth for this. And if you don't know, material design from Google, Backpack, Base from Google, Polaris from Shopify. I think Coinbase just recently outsourced their design system, which is really good. Now, for us, we started it inside of our project. We had the components folder. You can see it on the right there, where we kept all of our dumb components, let's say, like accordions, avatars, buttons, whatever. And of course, this worked, but as soon as the team grew and grew and grew, more logic kept creeping inside of the components. We have pull review, code reviews and stuff like that, but it still crept through, like our components were no longer as dumb as they were supposed to be. Implementation logic and business logic was entering the components, which we didn't like. And we started to build more and more products. We already had like 4 products inside of the app. And in the beginning, when we had 2, we duplicated the components folder in 2 repos. But then we decided, OK, it's time to extract this into an NPM package. So it's reusable, and it's the single source of truth for our code. And we thought, OK, in and out, 20 minutes adventure. We just copy-paste it. It's going to work seamlessly. And that was not the truth. I think it took us 6 months to extract 70 components that we had from 2 projects in an NPM package. The biggest problem was that we had a lot of tech debt in our code. We had a lot of leakage. We had our components somehow manage our button component in one project and our button component in the other project were totally different at one point. And we don't know how that happened. So we went back with Figma as a sort of truth. We branded the component library. We called it Coco after our office dog. We assigned a project lead to Coco and ownership of all the components repos. So every time someone tried to make a modification inside the components of the project, they would get instantly rejected and say, you're not allowed to touch this code. You have to extract this component in Coco, the NPM package. You need to add Storybook. You need to have a CI/CD pipeline for accessibility and sort of all sorts of stuff like that. That really, really helped us with this. Now, another problem we had when we hit a lot of users was we had our product, we sell it to universities. And we onboard students on the product, usually in a town hall like this. We have students come in an amphitheater like this. They bring their laptops, and we tell them how to use the app. It's sort of like a workshop with hundreds and hundreds of students, sometimes thousands. And because all the students had their laptop and they were using a Wi-Fi connection, we had this problem where our front end was hosted on app.thecareeros.com. Our API was on api.thecareeros.com. And we were making a lot of requests to the backend, like I said before. And the local Wi-Fi was at this point cutting requests. It was blocking them because we were making too many pre-flight requests to our backend because we were not using the same origin. So because of our options and pre-flight requests, our app stopped working. To make matters even worse, we saw nothing of this. We had people calling us from all over the world, our salespeople telling us, the app is not working. And we were like looking at metrics and like, works for me? What do you mean? Sentry says we're up, our CPU is at 10%. Nothing can go wrong, what's happening? And I was like, no. And they were sending videos of the app like just loading and not doing anything because the Wi-Fi was blocking all the backend requests. And of course, our first idea was, well, let's just buy some Starlinks and just go with the Starlinks so they use our internet and not use the shitty university Wi-Fi that they had there. Because initially we thought it was the Wi-Fi's fault. But actually was because we were making requests to not the same origin. So what we did to fix this is basically we created a proxy for the requests. So instead of making requests to api.dockeros, we were making them to /API. So it was making it to our app.dockeros/API. And we created a redirect inside of Netlify, which is our hosting provider, to our front-end hosting provider, to make to the correct backend request. And now we were same origin from the browser's point of view. We're not making any pre-flight requests, and the Wi-Fi's were stopped blocking us completely. But then we had another problem. We started, our app got built bigger. So with Lazy, we started lazy loading all of our main features, let's say all our modules. And if you don't know, when you do this, you basically load this feature only when you click on it in the nav bar, which is something you want to do. But then we started getting a very typical error in our Sentry, which is failed to import dynamic module error. And why was this happening? Well, when we were deploying, Vite, which is our bundler, was creating actually a chunk. So each of these modules was found at index chunk blah 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 .ts. And once we deployed the new version, well, Vite deleted all of the old chunks from our disk folder and created new values. And for people who are already in the app, when they clicked in their source code, in their source map, they had the old chunks there. And when they click a URL, we got the error page. And of course, Vite tells you, oh, you just add an event listener when this happens, Vite preload error, and you just make it window location reload, and then it solves all the issue. But it was not a good experience for the users because they saw their page reloading real time. And even worse, for old Safari browsers, this didn't work, and they got caught up in an infinity loop. Which is another story, but increased our cost for Mixpanel by 25% or something like this, which was very funny. So what can we do? Actually, our main idea, first one was, okay, just don't delete the chunks, the old chunks. We keep the old chunks. You make the deploy. You have multiple versions on the same app. And if a user is using the old version, they just keep using the old version. But if this solution, we had problems with backwards compatibility with the backend. Because if the backend expects something new and then they go with an old version of a GET request, then the app just breaks, which we didn't want. So what did we do? Again, we created in a web worker a solution where instead of, first, we deleted the chunks completely and didn't use like a random hash for our chunks. We used the app version number. So if our app version was 2.3.5, our chunks were index minus 2.3.5, whatever. And then we have a web worker that actually checks for the latest version in the app to a backend endpoint. And if it detects a new version in the background, it actually updates the source maps for the current users, so they always get the newest version. Now, all in all, it's been like over 3 years that we started, and we're pretty happy with how the project is currently in, right? We're still using the latest React. We upgraded to 19. We have the latest 10 stack. We're pretty happy. We actually managed to migrate from React router to 10 stack router because it has better TypeScript support. And we managed to keep technical debt as close to zero as possible while moving very, very fast in building a consumer-facing product. But a year and a half ago, that was not really the case. Our app was very slow. It was floated with bugs, functional or visual, and actually it was breaking during sales calls that our people were having. And it got to a point that they were making jokes that 60% of the time our app works every time. So how did we fix it? Well, first we started implementing no broken window theory, no broken window policy. So if you don't know, the broken window theory states that if a neighborhood has broken windows, it normalizes crime and it raises crime rates. And it happens in app as well. If you already have bugs in app, you can just pile them in the backlog, thus creating normality of the app having bugs and never fixing them. So we said, this was in 2024, I think, during the Summer Olympics, we said, okay, every day, every Wednesday, we have a day dedicated to bug squashing. A competition where developers take all the bugs from the backlog. Each bug has a certain point system, so you can win actually awards by solving bugs. And we even had like a bug squashing leaderboards where people can get medals, and if you had a medal, you got like Amazon vouchers and whatever. And it actually took me two weeks to find the one where I am at the top. So it got super, super competitive with everyone inside of the company. But that was just half the battle. Like, we wanted to make sure that functionality and issues don't keep creeping inside of the future. So we had to change a little bit our ways of working. So like I said before, our app was hosted on Netlify, and Netlify has this cool feature, but I'm sure every other hosting provider has it, where when you create a PR, it actually creates a deploy preview for you, so you can actually check your code and share your code with everyone in the company on that PR level. I built this before previously, but Netlify has it out of the box, and I think is really, really good. And we use this deploy preview to do testing. We give it to designers so they can give design acceptance on this PR review. And then product acceptance goes by the product managers, again at the PR level. So it makes sure that no issues happen on main. I mean, of course they do, but it solves a lot of like visual issues that we had. Then we created actually a pretty sweet release process. So every time you merge something, we have a GitHub action that looks at the title of your PR. And if in the title you have like feature or fix or major, it computes the newest version of the product. And then it puts all of these branches that you're releasing into the draft release that you have on GitHub. And every time, because we don't have CI/CD and we don't release as soon as you merge to main, we have manual releases that we do every day. But this way, we know what we're releasing at every given moment without actually checking the commits, which was getting harder and harder to do, to check what you're releasing to production. Then, to make sure that the team is working really fast, we made it mandatory for everyone to use Cursor. It was our favorite at the time. Now it's getting really, really slow, and I'm going to try something else. But everyone is using Cursor, and we created these Cursor rules where we tell it, okay, how do you are supposed to write React? How are you supposed to write our SAS files, because we're using the BEM methodology, and we want Cursor to know how we write the code, so it writes the same code as us. And of course, it has like guidelines on how to write tests first, and stuff like that. And this made it easier actually for our backend developers to jump inside of our code and code themselves, because Cursor took care of most of the issues, and then the other stuff were handled at the code review level. And when you open a PR, we have this template where we say, okay, what does this PR do before changes, after changes, implementation details, testing instructions, and then we have a quality checklist. And you can actually have like Copilot, or we're using Devin recently, to check if these quality checklists are actually working or not. So that's most of what we've done. I actually am here from Barcelona, and I'm hosting the React.js meetup, local meetup here in Barcelona. So if you're from Barcelona or around here for a while, check us out on Meetup, on LinkedIn. It's pretty cool, I would say. We have some really cool stickers. So if you're sitting here today wondering whether to take that leap, to build something new, to join a startup, to refactor that legacy code base, my advice is simply do it. Now, the punches will come. You'll figure out how to roll with them. Remember, everyone has like a plan until they get punched in the face. But with solid foundation and modular design, at least you'll still be standing afterwards. And if you want to learn React, I have a really cool small newsletter where you get some React tips every single day. 60 seconds, you don't have to read them very long, like use state, use context, state collocation, and stuff like that. And I would really recommend you check it out. And finally, I also have a podcast. I call it the Senor Developer. I hope I'm not offending any Spanish people. So if you want to check it out, the latest episode was with Eric, principal engineer at New Relic, and we talked about observability in depth and micro frontends. So if you really want something to listen to on your way home or on the flight, yeah, just give it a listen. Thank you. That was pretty fast.
So I think it's an amazing way of ending the day. And we have some questions for you, Dan, starting by, how did you convince your co-founders to invest in modular architecture, strict rules, etc., instead of putting together something quick for MVP?
Well, I didn't convince them, I just did it. That was the first part. Also, I told them from mistakes. Like previously, I worked at Glovo, and we tried to migrate from Nux 2 to Nux 3 for 2 years, and we couldn't do it. And in the end, we just deleted the app and built it again in Next. So I told them like horror stories that can happen, and it convinced them, okay, let's spend some more time into modularity. Of course, we had to balance the MVP. We had strict deadlines that we had to adhere to, but we found the correct balance.
Great. The second question goes as not a front end, but this seems to add a lot of complexity just in case. How many times did you benefit from the wrappers versus the time it takes to create?
That's a good question. Well, we benefited twice when React DND got deprecated and when we switched out React Router with 10-stack Router. I think the switching for React Router would have been impossible to do if we didn't have a router beforehand, if we didn't have a wrapper, which saved us a lot of time. And I thought, considering the effects, now with Cursor, if you want to build a wrapper, it takes you, what, 5 minutes, 10 minutes? Importing a package inside of your component takes as much time as telling Cursor, like, just build me a wrapper of this component. I want to use this, this, and this. So I don't think there's a big trade-off anymore. Of course, in the beginning, it was very tiresome to build a wrapper for each third-party application.
How atomic and molecule design helps to modulate the front end and create a real ports and adapter architecture?
So how atomic and molecular design? Well, atomic design I'm not really a big fan of it, talking about through atomic design like Tailwind. If you want to use Tailwind inside of your application, it adds much more complexity that you benefit from. Of course, if you start and if you do like a project from a small side project, it's very beneficial, but I would never use Tailwind or atomic design inside of my project. But the practices of atomic design, like building a component library from the start, building the smallest unit that you can, like for example, a button, and then going to a molecule and stuff like that, really helps you move forward. But it takes a lot of time and how do you say, like you need guidelines and rules in place to make sure you never go outside of the box, let's say.
Great. Why don't you use libraries because of permanent updates? Do you create and reuse your own libraries in your components of micro frontends?
No, we don't. I mean, the plan at the start was to never use third-party libraries, but of course that didn't work out. Like I showed you, it's much easier to use something from the open source community. They do an amazing job, and I didn't want to use third-party libraries in the start because of the horror stories that I had in the past, where it was super hard to upgrade the library or change frameworks. And specifically, I didn't like UI-specific libraries. Like, for example, there was one in Vue, I forgot what it's called, but it was basically all the inputs, all the drop-downs, everything. If I had to use like a drop-down, initially I tried to build my own, but of course it's not as good as the drop-down built by an open source project on the market.
And the last one, have you tried UI testing as part of CI/CD? It's like Cypress or Playwright. If so, what was your experience?
So UI testing, I tried it at component level using Storybook. So in Storybook, you can create like UI tests. It uses Playwright in the background, so you can have accessibility tests. You can have visual tests that checks if the component has changed and then asks you, okay, is this intentional or not, which I found really good. But we never built end-to-end tests, true end-to-end tests inside of my project now. Because again, I had really big problems with them before, and I decided they bring much more issues that they solve, at least at this moment. We have a lot of component testing, integration tests, and unit tests, which I think catch most of the issues that we're having.
Thank you.